University of Alabama at Birmingham is a top research university in the South. We have a very good College of Arts and Sciences. This is a newly formed college, and we have about 15,000 undergraduate student population.
From biomedical research to engineering to computational sciences, there is a huge amount of data, and the analysis requires a huge amount of compute power.
University of California, Irvine takes extreme pride in its deep research capabilities.
We're doing research in computer-aided drug design, and we're trying to exploit new structural information that we gain out of large-scale biophysical simulations. So the compute power that we need is very crucial for us.
The University of Louisville is the largest metropolitan university in the state of Kentucky. We have a PhD graduate program in computer science engineering. Our strength has been in areas such as knowledge discovery and data mining and bioinformatics.
My research area is in bioinformatics, which is looking at DNA and protein sequences and using algorithms, using databases to parse out information from those.
Texas Tech University is a major research university. We work very closely with physics, chemistry, chemical engineering, geosciences in particular. You just cannot support the level of computation that the researchers demand if you don't continue to grow.
The ICBR, the Interdisciplinary Center for Biotechnology Research at the University of Florida, we are a research support organization to aid life sciences research across the entire spectrum of the university's functions.
Next generation DNA sequencing is allowing us to do things that we couldn't do before. We are now able to produce data that's on the order of thousands of times what we could produce just a few years ago.
We're generating data and using it and reusing it, combining it. It puts tremendous stress on the infrastructure to handle that information. That's the game now. It's all about how we handle that information computationally.
Our research is to simulate at the atomic level the behavior of molecules. The ability to use larger and larger and faster computers really opens the door to new discoveries. Without high-performance computing, we can't do this research.
Green Planet is a 307-server, leading-edge, high-performance compute cluster.
It allows us to access pretty much as many nodes as we could possibly need. And so what that allows us to do is basically get going with results much more quickly.
High-performance computing allows us to leverage the power of many versus the power of one. And with faster connections, faster processor, multiple cores, we can leverage this to develop algorithms that can respond in real time and enable faster discovery.
The latest purchase from Dell was the Rushmore cluster that's primarily used for fighting cybercrime.
When we first moved our spam data mine onto the new cluster, we immediately saw about a 20-fold performance over our previous work. We began to study how to spread the problem set across all the different processors we had available now. On the Dell multiprocessor solution, we're able to get 80-fold improvements over that original 20-fold. It's just blazing fast.
To come to a university where there's such a large cluster facility is really wonderful. Before, we would do simulations on our little desktop systems, and they would run for 2 or 3 months. These days, I can do the same simulations in a couple of days.
We're transforming the way life sciences research is done because of what the technology enables us to do.
We can simulate larger problems, both in terms of the size or in terms of the time. In our business, that's huge.
Because we were able to do some simulations and we were able to produce some papers, get preliminary data, we get more fundings, which in turn we can hire more people, more students to continue work on the same project.
It's really exciting to work in an integrative environment where you have people from different disciplines. You get to hear things that you're not an expert in, but you can have some contribution to. And so I can't really imagine life without high-performance computing.
The thing that I find most fulfilling about my current job, it is the interactions that I have with the students and being able to see that aha moment when they discover something. That's really nice.
The type of system that we can study has been completely changed. So it's really transformed our research.
These discoveries that we're making, we are basically enabling new methods. The payoff really, I think, could be huge.
Our collaborators from other institutions are now looking at us as the way of the future.